Hi data people, welcome back to my channel for tech career, data science, and machine learning. So in today's video, we're going to go over Python for data science and specifically for merges and reshaping your data frame or data sets. So there are four main types of merges I want to talk about. So if you know SQL, it's pretty much the same thing as using joins in your SQL. And if you know Excel, then it's pretty much the same thing as using your Vlookup or index match with your two different sheets. So the four of them are, inner merges, left merge, right merge, and full outer merge. And I'm going to show you, help you, visualize it with these Venn diagrams. And so the first one is that you're only taking everything in the middle. So that means if you have two different sheets and you have, some commonly shared value between the two sheets that you have, and based on the key that you're trying to, match with, then you'll only keep all the rows that actually matches from both sheets. A left merge is that you keep everything from your first sheet and then try to look values from your second sheet. And if it's not, the second sheet, if it's not available in the first sheet, then those will not be, moved over. And then you have right merge, which is keeping everything on your second sheet and then try to merge everything on your from your first sheet. The full outer merge is like you have two different sheets and you try to look for the common values between the two sheets, but also still keep all the values that are not even matched with either of the sheets and keep all the values together. The left merge is probably like the most commonly used merges that you will be using because that's very common that you have some sort of ID and you need to look up, who it is or like get more details about this ID so that you can get a, full picture about for this table, right? So in this case, it's very commonly used that you have order sheet and you have customer sheet, and in your order sheet have the customer ID, but then you don't know who the customer ID is unless you go look into your customer sheet, right? And then in this case, you often will do a VLOOKUP to try to look up who that person is. And then so you can have their name in the order sheet to help you, come up with metrics or like break it down even further more. And you can do exactly the same thing in Pandas by doing this PD. So PD is the Pandas package. When you do import Pandas as PD, that's how you'll be using your PD. So you do a data frame that you newly created from having these merges equals to, so you're essentially creating a new sheet with this. That's what it is. And equals to pd.merge, and then you've put your first table, which is your left table, which is your orders table, comma, your right table or the second sheet, which is your customers table, and then you'll say how equals quotation mark left. So that will tell Pandas that you're doing a left merge. And on, so every time you do your merges, you have to do it on syntax, because that, when you do your VLOOKUP, you're also looking up for a specific column, right? Like in this example, we're looking specifically at column B or B2 in this case, so that's our customer ID. So we need to make sure that we know, on top of knowing what merges that you're using, you also need to know what ID or what column you're looking at to make the merge. And now we're going to cover inner merges. So remember that the Venn diagram, inner merge is the one that is only keeping a record that's like, that's blending, like that's shared between both sheets. So only the middle part, right? So then that in this case, when you have customer ID and when you try to look up your customer name again, in this case, we have some blanks in our customer ID, like the nulls. And then because it's blank, so then when you try to look up your customer name, it wouldn't be able to show up. So in this case, because there's no customer name showing up for those two rows, like the row 10 and 12, that those two rows will be eliminated in your inner merge. So keep that in mind, that you only keep everything that you have in common from the two data frames, so that you want to make sure that that's what you want at the end, that you don't want any, it can also kind of work as like a filter to filter down to, only the customer ID that's shared between the two data frames. And you can do the same thing by PD, which is Pandas package, pd.merge orders, comma, customers, and how you'll change it to inner, and then on customer ID, the same thing. And you can so if you're trying to do multiple merges, I wouldn't recommend you to name it the same thing as DF all the time. That's actually not a good practice, because you want to make sure that your data frame is not always the same name, because it overwrites itself. So make sure that you have maybe like DF underscore inner, so that it tells you that you're doing inner merge instead of a left merge or something. So now we're going to cover the outer merge, which when you after you do your VLOOKUP, all the blanks that didn't find any matching value, those are all gonna stay. And on top of that, anything in the customer's table that has customer name that's not mapped into any customer ID will also be brought over, but we'll have all the blanks for all the other columns like order ID, customer ID, because they don't have any matching value. But the general idea is that you are bringing everything from both sides of a data frame and into, you're trying to merge them into a bigger table that has all the information from both tables. And you can do that by, using the same syntax of pd.merge and then orders, comma, customers, how you're doing outer this time, and still on a customer ID, and that's how you accomplish this. So before I jump into reshaping the data, please make sure you subscribe to learn more about data, tech career, and machine learning. And also let me know in the comment below to, what are you interested in learning Python for data science, and what projects you have in mind. So melt is pretty much like unpivoting your pivot table. So in this case of scenario that we have customer ID, and then you have product 1 count, and then product 2 count, and then you might even have product 3, 4, 5, or however many, then it's kind of hard to, try to sum all the products that you have, because you can do, well, in this case, before you unpivot it, you can do like product 1 count plus product 2 counts to get a summation of product 1 and product 2. But imagine if you have like 20 products and it's really hard to, keep adding like with a plus sign. So then what you want to do is that you melt it, so you unpivot the table, and then you can do a simple sum function in this case. Can be accomplished by using PD, which is your pandas package, .melt, and then your data frame. So if you want to pivot, then you have to use a pivot function, but keep in mind there are two different pivot functions. And early on in my career, I really got confused about them too, and I didn't know what the difference is. But let me give you a high level of what the difference is. So the high level is that pivot is straight up just pivoting without doing any aggregation. And then the next slide, I'm going to show you the pivot table, which is the same thing as pivot, but you are able to do aggregation in your pivot tables, such as like summation or taking a maximum, or any other aggregations that you have. So in this case, to have the same results for pivot and pivot table, then you have to make sure that your data is already pre-aggregated for pivot. Otherwise, it will not be, doing any aggregation. It's just gonna straight up put everything into a pivot, and that, you're gonna have duplicated data. So here you can do the pivot by df, which is your data frame, dot pivot, parentheses, index equals your customer ID that we're using here, and then columns is your product. So I want to pivot my product and customer ID into, a pivot table, and then my values will be a product count. Notice that, my values is straight up just a product count, and I'm not doing any aggregation or summation or maximum function here. And then I'm renaming this data frame that I pivoted to df underscore pivot, so that you have to make sure that you name it as something else, otherwise it will just print out the results. I personally think the pivot table function is actually probably a lot more used than the pivot function, but a pivot function just to tell you that there is a difference between pivot function and pivot table function, so keep that in mind. But you know how you do your pivot table in, in Excel, where you do the rows with customer ID and values and columns with product, and you will be able to do that by having a summation of product counts in Excel. So you can do exactly the same thing by doing PD dot pivot table, parentheses, your data frame, and then your index, defining your columns as your product, and then do an ag function. That's the major difference here, is that you're actually able to, change or do some aggregation for the values that you're putting in. And if you have more than one column that has values, then you can specifically say what your value is, the value that you're using, by adding values equals the column that you're going to use into one of your parentheses arguments, and then you'll rename this as a df.pivot underscore pivot table, and this will be your new data frame that you're going to work with after you already pivoted table. And then from there, you can, do a lot more of visualization into maybe bar graphs or time series or other types of charts. So quickly cover what I talked about today. So first we talk about different merges, which pretty much works like your Vlookup or index matches to, look up some value. Depends on if you want to keep all the values, or which is a full outer merge, or you want to just do a left merge, which you're keeping everything on the first sheet, and your inner merge, which is only gonna show all the data that you have that has shared between both sheets. And then I also went over melt, which is like pretty much like unpivoting your table. And then we also went over the difference between pivot and pivot table, and to make sure that they're actually very different depends on how your data frame looks like. But I would say that pivot table is a lot more used in general, because that your data frame or data set might not be already aggregated, depends on how you have the data set up.